Well, guys, let's now look at a few examples. Question 1. To determine the period of a pendulum, a student measures a time for 20 oscillations which took 27.80 seconds. Why didn't the student measure the time for one oscillation right away? Why measure 20 oscillations and time all of them when you need the time for one oscillation? That's the question. B, calculate the period of the pendulum. C, calculate its frequency. So let's start with A. Why did the student time 20 oscillations to determine the time for one oscillation? Okay, the answer is here: to minimize reaction time error, or to reduce reaction time error, right? So the spelling for reaction is wrong. There has to be an A here. Well, the solution to minimize reaction time error, I have corrected it. It's reaction time error. If we want to go into details and explain how we mean by that, I have included here. Using a stopwatch introduces human reaction time error. Timing more oscillations reduces reaction time error as the error is spread over a large number of oscillations. So that's just an explanation for understanding or clarity. So let's look at B. So B, calculate the period of the pendulum. What is a period of a pendulum? A period of a pendulum is time taken to complete one oscillations. How many oscillations did we time? 20. So the 20 oscillations, they are going to share 27.80 seconds equally, because we want to know how much time each oscillation take, right? So that's it. So it's time, period, time taken to complete one oscillation. Period is denoted by capital letter T. So the units have to be in the units for time, because period is the time divided by number of oscillations. So time taken 27.80 seconds divided by 20 oscillations. So what do we get? T is equal to 1.39. This is what we get when we punch our calculator. So the period is 1.39 seconds. So each and every oscillation takes this much time. So if we multiply this by 20, we should get 27.80, because there are 20 oscillations. Each of those oscillations take this time here, 1.39 seconds. So that's it. Let's look at C. Okay, C, calculate its frequency. What is frequency? Frequency is the number of oscillations generated in 1 second. Number of oscillations generated per second. So is T. So I mean F is equal to N over T, which is 20 divided by 27.80 seconds. So let's punch our calculators and see what we get. 20 divided by 27.80. What we get is 0.72. That is two significant figures. F is equal to 0.72 hertz. It's in hertz, right? So it is in hertz. So that's the frequency. So also we can determine frequency from period. As you can see, T for period is equal to time divided by number of oscillations. Frequency is the number of oscillations divided by time. So if you have frequency, you can find period from this formula, or if you have period, you can determine period from 1 over f. So you can do that and see if you get the same answers, right? So that's it about pendulum. So this is the end of our topic, length and time. So now we are going to solve questions. We are going to look at exam questions. We are going to develop a quiz, assignments, and a test really. Yeah, thank you.